In this video, I want to talk about the idea of perimeter. And perimeter is measuring one dimension, and that dimension is length. So it's measuring the length around the boundary of a two-dimensional object. Now here's a two-dimensional object that I just drew. It's kind of this curvy little blobby thing. How would I measure this? Well, one way I could do it is I could take a piece of string and start wrapping it around tightly around this object. And then as I wrap it tightly, I keep track of where I started. And when I get to the point where I started, I cut the string, then I take the string and I lay it out flat and then measure with a ruler. So that's always a way that you can measure perimeter of any object that you like. But for a lot of objects, they're fairly simple, or even better, they have some sort of symmetry going on that we can use to help us determine the area of some two-dimensional shape. For example, here we have a rectangle. And we know with a rectangle that opposite sides are congruent. So if we know that this side is, say, 4 meters, and this side is 1 meter, well, we know that the perimeter for this, well, here's a side length of 4, so this side also has side length 4. So we know that we have 2 copies of 4 meters that we need to add together, and 2 copies of 1 meter, since this side is also 4 meters, and this side is also 1 meter. And that's always the same when you have a rectangle. It's 2 copies of the length plus 2 copies of the width. And you get, in this case, oh, that's not the pen I want. This is 8 plus 2 is 10 meters. And if you had a different figure, like a square or something like that, you could use the symmetry properties and the congruence properties of that square to help you out as well. And we're going to do similar things to this as we go forward in this section. So here's an exercise here. I have a shape in black. Here it is here. It's kind of made up of a bunch of rectangular pieces. And I gave you the measurements of a few of the sides. So the top is 7 meters long. This side is 2 meters long. This side is 3 meters long. This side is 5 meters long. And that's all I'm giving you. But I do want you to find the perimeter. And I put these kind of yellow markings in here just to indicate that, hey, we are dealing with all right angles, so everything lines up nicely. And these dotted, what do I want to say? These dotted yellow lines here mean that kind of this bit is a rectangle and this bit is a rectangle. So this side here is congruent to this side, and this side here is congruent to that side. And, of course, this side is congruent to that side. So maybe pause the video now and see if you can solve this problem. Okay, now that we're back, let's fill in some details that we can get. So, I know that this side here is 3 meters, so this side is 3 meters. So I can put that in, that's going to help me. 3 meters. Okay. What else do I know? I know that this bit here is 2 meters, since it's the same length as this, since this is a big old rectangle. So this is 2 meters here. Let me fill that in. And I know this length is 5 meters. So from here to here is 5 meters, and from here to here is 2 meters. So in total, 5 plus 2 is 7 meters. Okay. So in some sense, that's all we get from this diagram in terms of using some measurements. Almost. Now you can see here there's 4 sides we're not given the length of. This side here, this here, this here, and this here. So let me label them. I'm going to call this one A, this length, B, this length, C, and this length, D. So they're the unknown ones. And there's kind of nothing around that gives us any information to figure out any of these individual measurements. But if you think about it, the top is 7 meters long. So the bottoms combined, since this is kind of like a big old rectangle, have to be 7 meters as well. So our bottoms are A, B, C, and D. So the sum of these has to be 7 meters. So even though I don't know the exact length, I know that the sum of these guys is 7 meters. Okay, so the perimeter of this, well, let's start, say, at this 2 meters. Let's start here, and let's go around this way. Let's go, I guess that's counterclockwise. Okay, so we get 2 meters plus A meters plus 3 plus B plus 3 plus C plus 5, just to make sure you understand what we're doing. 2 plus A plus 3 plus B plus 3 plus C plus 5, and we continue. Plus D plus this long side, 7, plus the top, another 7, and they're all of my sides. So let's combine this. So combine our constants here. We have 2 plus 3 plus 3 is 8, plus 5 is 13, plus 7 is 20, plus another 7 is 27. So we get 27, and we still have our A plus B plus C plus D. But we know A plus B plus C plus D is another 7 meters. So this is 27 plus 7, which is, of course, 34 meters. So again, using some of the ideas of how rectangles work, we were able to figure out the perimeter of this object, even though we didn't know some of the lengths directly. We didn't know A, B, C, and D. Let's do one more. So this drawing, it's kind of hard to draw on this pad, so excuse the non-straight lines, but this is supposed to be a straight line that comes to a right angle, and then goes across, and then goes up, and then there is another straight line joining the end of this line with the end of our first line. Try and make that a little bit straighter. Okay, so I gave you some measurements. The left side is 10 meters, the right side is 7, and the bottom is 4. So see if you can figure out the perimeter of this object. Well, we almost have it. We just need the length of this side, and that'll give it to us. So pause the video now and see if you can figure that out. Okay, now that we're back, hopefully you realized that, well, what I could do is I could kind of split this figure up and make kind of a rectangular bit here, and then on top of that rectangular bit, is a triangle. And in fact, since I drew a line perpendicular to the bottom here, that makes this angle a right angle. So I have a right angle triangle. And since this is a rectangle, I know that this length is 4 meters. And, well, what's this length here? Well, the right side is 7. The left side is 10, but that means that this bit must be 7 since it's part of a rectangle. So the rest of it must be 3 meters long. So we have a right angle triangle where we know the two non-hypotenuses. We call them the legs of the right angle triangle. So we can use the Pythagorean theorem to solve for the hypotenuse. So let's go ahead and do it. We know that a squared plus b squared equals c squared for a right angle triangle, where c is the hypotenuse. So we get that 3 squared plus 4 squared equals c squared. So that is 9 plus 16 equals c squared. That's 25 equals c squared. Take the square root of both sides, and we're only interested in the positive answer since you can't have a negative length. So we have 5 equals c. So we know that the hypotenuse is indeed 5. So the perimeter of this object, well, now it's pretty easy to figure out. We'll start at the left side. The left side here is 10 meters. The bottom is 4. The right side is 7. And that diagonal hypotenuse bit is 5 meters. We add that up. We get 10 plus 4 is 14, plus 7 is 21, plus 5 is 26 meters. And again, you can use the idea of breaking your object up into shapes that you know some things about, and that'll help you solve for some unknown lengths of the sides, as we did in this example and the previous one. I want to talk about the perimeter of circles now. And circles, well, let me talk about the parts of a circle. And you can think of a circle as follows. So, kind of the basis of a circle is a radius. And so you pick a radius, which is, it's a line segment from the center to a point on the circle. So any line segment that satisfies that is a radius, of course. So you can make a circle by taking a line segment with the radius that you want, putting it down, putting, say, your finger or something on one end, and that'll be the center of your circle, and then sweeping the radius around so that the other end draws out the boundary of your circle. So that's really how you can think of a circle. And some other parts, of course, there's the center, which we talked about. There's the radius. There's the diameter. So that is a line segment from one point on the circle to another. And of course, the important bit here is that it's through the center. So any line segment that you draw from one point on your circle to another, but through the center, is a diameter. So we have a diameter. And the perimeter of your circle we call the circumference. So that is the length of the outside of your circle. And there's a fact, and it's kind of a, in some sense, astonishing fact. Take any circle that you like, measure its circumference, measure its diameter. You will always get this number pi. And that fact had been discovered in ancient Greece thousands and thousands of years ago. So it's a very old fact, a very interesting fact. And pi is, of course, this 3.14159265535, whatever. But it's an irrational number. There's no repeating part in the decimals. But for our purposes, if we're doing any calculations, we can approximate pi to be 3.14. That's good enough for our purposes. But the way we can think about this is that we can say the circumference is always pi times the length of the diameter. So in fact, if we do want to solve for the circumference, we can just rearrange this formula. Multiply both sides by d, and we get that the circumference equals pi times the diameter. Another way you might see this expressed as well is in terms of the radius. If we look here, the radius is half the length of a diameter. So if I have a diameter, it's twice the length of the radius. So another relation is that a diameter is twice the length of a radius. So if I replace d with 2r, you get c equals pi times 2r. And usually people express it as the circumference equals 2 times pi times the radius. So your circumference is indeed that formula there. Now we'll do some examples calculating this, or at least one specific instance where we need the circumference to calculate something. Okay, here's what we want to do for this question. We want to find the arc length, and I'll talk about what that is in a second, of a 143-degree sector of a circle where the radius is 6 meters. So a good example when you're given a problem like this where there's some stuff to draw, you might as well sketch it. It doesn't have to be a perfect sketch, but a sketch nonetheless will help you just visualize what's going on. So just to kind of reiterate, I don't need to make it perfect. I'm going to try and do this by hand. It might not be great. Who cares? There's my circle. That's good enough. Here's the center of my circle. I know that the radius, we're told the radius is 6 meters. So I'll put that in. And I'm told that we have a 143-degree sector of a circle. Thinking of this, I know that a straight angle is 180 degrees. I know a right angle is 90 degrees. So it's going to be somewhere in between there. So maybe even a little past halfway. You could work that out if you're very curious. So this is 143 degrees. So I want to calculate the arc length. So the arc length is the length of the arc of that sector of my circle. So that bit there. Now remember, we know the radius of our circle, and we know the formula for the circumference is 2 times pi times r. So think about how to solve this problem. Remember that we have 143 degrees of our circle, so that's the sector here. So think about how you can use that to be able to solve for this arc length here. Remember, degree just means 3/60ths. So if I have 143 degrees, I have 143 3/60ths of the circle. So think about that. Pause the video now. Try this problem. Okay, now that we're back. Well, we need the circumference anyway, and then we need a piece of it. So let's calculate the circumference. So the circumference is 2 times pi times the radius, which is 6. I'll put the units in at the end. It'll be meters. So this is 12 times pi. And I'm just going to leave it as 12 times pi for now. If you wanted to approximate it, you just let pi equal 3.14. Do that multiplication, and you get some approximate value. But I'm going to leave it as 12 times pi. That's fine. So we need 143 degrees of our circumference. So we need, I'll write it out in words, 143 degrees of the circumference. And how can we express this mathematically to help us? Well, remember, degrees means 3/60ths of a circle. So we need 143 3/60ths of our circumference, which we calculated to be 12 pi. And again, if you're unsure how to come up with this, it's a good idea to see if you could solve a similar problem. So maybe 143 degrees will kind of throw off how to think about it. But maybe if you had 180 degrees, if it was half the circle, you'd think, well, how can I come up with a formula using 180 degrees? And I know it's just going to be half my circumference. So thinking of a simpler problem might help you how to solve a problem where it's really just the number here that's making this problem a little harder to think about. Okay, anyway, we basically wrote down our answer. We just need to simplify this a little bit. So I'm going to simplify this. I see a common factor. We can think of this as 12 pi over 1 if you like. I see a common factor of 12 and 360 and 12, so I might as well divide that out. 12 divided by 12 is 1. 360 divided by 12 is 30. And I don't see any more common factors around, so I have 143 times pi in my numerator and 30 in my denominator, and that's in meters. And if I want, this is a fine answer. This is, in fact, I would say an exact answer because it's in terms of pi. I didn't do any approximation or rounding. This is an exact answer. But sometimes you need some approximation. So let's do an approximate answer where we let pi equal 3.14. So we're going to do 143 times 3.14, let's say approximately equal actually, over 30, and calculate that. And I'll leave that as a little exercise for you, but nothing too bad. I will say that you'll get to 2 decimal places 14.97 meters. So the length of this arc here is 14.97 meters.